world is
There we go.
we're okay. It's the virtual world. It's been a very bumpy orbit, I guess, if you want to call it that, a little orbit plus, and hopefully things will smooth a bit out as we take our next trip around the sun. Just curious, how many saw the eclipse yesterday morning? Anyone out there? Just give me a shout out, or you can mic up or unmute yourselves. I'm gonna see if this works. Here's some pictures we took. Can you guys see that picture?
Yeah.
Okay.
Yeah.
As I click through. So this was taken through a 6-inch telescope. And this was the first sunrise eclipse in Milwaukee area in 48 years. The last time the sun rose eclipsed was 1973. So it's just kind of cool to see that. We just got a break. It was cloudy down by the lake, but the sun was powerful enough to kind of pierce through these clouds. And Peter Chow, oops, that one, yeah, there. Peter Chow took this one. He's in the Urban Astronomers group. He joined us down there, and he got some nice pictures with his camera. So the next solar eclipse that we're going to see is not until October 14th, 2023, if you want to mark your calendars for that. And then don't forget, mark your calendars also for April 8th, 2024. There'll be a total solar eclipse. The one in Milwaukee, that will be about 90%, and we do encourage you to travel. The museum here will have a trip to Texas, the San Antonio area, so stay tuned for that. In about another, about another year, we'll have details on that, probably end of next summer, 2022, we should have details on that trip. But it's about a 4 or 5 day trip looking at some museums and natural sites. And then, of course, a whole eclipse day, which will travel a little bit west of San Antonio. So back to the sky here, I'm going to ask you sort of politely to hang on to your seats or hold on to whatever you're sitting in, because I've been teaching this stuff for a long time, but it still amazes me. So here's west over to your right here, the W for west, and there's the sun going down over here. The reason I tell you to hold on, because as you know, the sun is not moving, we're the ones moving. So with the magic of the planetarium, we can simply speed up time. And we just made an hour go by. And I don't know if you're gonna see it tonight. This is a really tough one, but I'm gonna give you homework on a Friday night. So this sunset's about 8:30, a little after that. This is about 9:10. And can you guys see right over here? You'll see the mouse. My mouse, come on, I use it as a pointer. There's Venus, very low in the sky, but you can see it. And then just below is the moon. So we just had the eclipse yesterday morning, right? And so the moon has moved in its orbit out from the alignment, and it's swung out, and there's going to be a skinny, skinny crescent moon. Kids like to call it the fingernail moon or the banana moon, but it's going to be really thin and really faint. But see if you can spot that tonight. So Venus and the moon, and with the magic of the planetarium, let's click ahead here. You're gonna see this screen here. I'm gonna try to, oh, this is hard to do with the Zoom thing. Hang on, I can move that Zoom menu. Okay, hang on just a sec. I want to show you where the moon is going to be the next couple nights, so you can spot it. And all right, so here is tonight, the Friday the 11th and 12th, and I'll go back to the screen. So here's the moon tomorrow night and Venus. And then of course the moon will keep getting bigger and bigger. Now we're gonna get darker here in a moment, and it's kind of hard. I'm gonna ask you, in fact, I'm gonna turn off mine right now. I know some of you are outside, I can tell, but turn off your lights if you're inside. And I'm gonna darken my room. You'll see me come back, maybe. I can't even see me with the camera. I've just turned it dark. So darken your room if you can. Turn off all your lights or close your window shade. I forgot to mention that at the start. So, and you can just see everything much better on your monitor, on your computer. So there's the moon, and there's Venus, and here is Mars right here. Now Mars is not very bright right now, but that's where the moon will be. If we jump ahead to Sunday night. And you'll see that the moon is, I think in this is the eclipsed Mars. They're going to be very close on Sunday night. So a great weekend for Venus and Mars, again, if we get clear skies. And we are going to jump back to tonight, Friday, the 11th. There we go. And then go back to our sky. All right, and then we can have some fun here. We know these are Venus and Mars because we can just zoom them up. So here comes Mars, and I really hope you never see this in the real sky. If you do, call 911 or something, or run for it, and then might as well zoom up Venus. So these are our neighbors, right? Venus toward the sun, and Venus is getting eclipsed by the moon there a little bit. Venus is very hot. Temperatures are about 900 degrees Fahrenheit. And the reason for that, and the reason we have to worry, is a lot of carbon dioxide in the air on Venus. In fact, it's just a very, very different world. So, and Mars is cold. It has carbon dioxide too, but the air is very thin, so it doesn't trap enough heat. They're pretty sure that Mars had a much bigger atmosphere, and the carbon dioxide trapped the heat, and Mars was much warmer. And that's why we think Mars possibly had life. I mean, it's a big if, we don't know, but we're going to show you the Perseverance rover that landed there back in February, mid-February, you may recall. And you think about the kick I get out of this is, you know, they spent many years building this, designing it, all that, launching it. Took 7 months to get there. It was launched last July. So all the scientists and engineers are just on the edge of their seat waiting for the signals from Perseverance here and whether it was successful. So they call this whole descent the 7 minutes of terror, from when it hits the atmosphere till the rover is on the surface. Takes about 7 minutes, and it's nervous watching them being so nervous to make sure that this is successful. So that's Perseverance, been there for, boy, over 3 months now. It's got that little helicopter you might have heard of, Intrepid. And one thing that Perseverance is going to do is make a rock pile of rocks they think have good possibilities for life, you know, signs of water in those rocks. This laser thing has spectroscopy, which tells the scientists what's in those rocks. That's how they can figure that out. They call it mass spec on the detective shows on TV. It's just a mass spectrometer, and then they can tell what's in those rocks chemically. So Perseverance is there. Curiosity, a rover, was landed, what, 9 years ago? My goodness, still working great. The United States has, how many spaceships there? I think 8 working spaceships at Mars right now. So if you're wondering why, you know, you get taxes taken out of your paycheck, remember that you help fund all these through NASA. And if you're thinking that's too much, just remember NASA is a very, very small part of the federal budget. It's like 0.4%. So it's quite small, but still significant. It's about $20 billion a year, but that allows us to do these great things and explore our neighbors in space. Now, obviously, this is a city sky. Most of us live in the city. We're going to take you to a darker sky here in just a moment. And let's just want to point out some bright things that you'll see probably from the Milwaukee area. This bright star is Arcturus. It's a little hard to see, but here's the Big Dipper right here. Now you should see it. It depends where you live, of course, exactly, but you might see the Big Dipper at the top of the sky. This is Spica, another bright star in Virgo. This looks like Mars, but it's Antares in the Scorpion. And these three over here are what they call the summer triangle in the sky. If you're getting a little hungry, I call it the big pizza slice. This is what I call an urban, and you guys are the Urban Ecology Center. I call these urban constellations because, you know, that's all we can see in the sky. We only see a handful of bright stars. So we sort of make up these modern or urban constellations. So we do it when we can. So let's get darker. Let's get away from the urban area here for a moment and spend most of our time here just looking at the sky far from streetlights. And it's a bit tough this time of year, as you might suspect, with the short nights. The sun doesn't get that far below the horizon. I just wrote a column for our newsletter about, there's only 4 hours of dark skies on a summer's night near the solstice. So here we are. So we're getting away from the streetlights a little bit, and you usually see a blue haze around the horizon, so we kept that up. And you'll notice Venus went down really quick. The moon went down really quick. It took a while to drive out here. I'm guessing this is about 10 o'clock, maybe 10:30. So if you're up a little late, but our Milky Way is a little overexposed here. I could adjust some of these things, but I'm not. And so there's the Milky Way, and now you can really see the Big Dipper in the sky here. No problem. You can see the Big Dipper. And many of you know this trick. We'll put the Big Dipper up there. I think some of you know the star hopping tricks with the Big Dipper, but if you guys want to, reach out onto your computer, your sky, and I want you first to connect these two stars in the Big Dipper's bowl. And I'm sure many of you have done this before, but go ahead, connect those two, and we'll help you out. And you point to Polaris, or the North Star. That's the one that doesn't move, and all the other stars seem to make a circle around it. And if you want to try that again and keep going, some of you know that the next one is, I gotta find it here, this is how you find Leo. Sorry, I can't see usually have that bigger. Down below, I'll get back to Cassiopeia, but down below this backwards question mark right here is Leo the Lion. So it's always underneath the Big Dipper. So you go to the North Star, okay, but if you go the other way or below the Big Dipper, you come to Leo. And you can again see this kind of backwards question mark right here, this little hook. I don't know if you're seeing that on your screen. Again, darken your room as best you can. This triangle right here is the back end and the tail of Leo the Lion. And so, hang on, I'm going to try to make this screen a little bit bigger so then you can see what I'm doing. Okay, so if you point to Polaris or the North Star, and then you can speed on or keep going to Cassiopeia, that W in the sky. We like to think it's the W for Wisconsin, or perhaps an M for Milwaukee. But if the Big Dipper is high in the sky, the W or Cassiopeia is going to be low. And this whole thing is like a clock. The North Star is the center of the clock, right? Or Polaris, it doesn't move. And so these just go around counterclockwise. They neither rise nor set during the night or any night. And the Egyptians, they would call these stars the imperishable ones. This is where the dead pharaohs went. Some of the pyramids are aligned to this northern sky, because obviously they were seen as gods, and so they stay up there in the heavens. So these stars near the North Star are all dead pharaohs or imperishable ones in the sky. So that's how the Egyptians looked at the sky. There's so many, it's a great way to learn the sky, all the different interpretations of what's going on.
Bob, even if this is Tim, even if so Egypt is fairly low in terms of latitude, and I'm just trying to think, would that make them set less or more?
There would be less stars that would be circumpolar. You're correct. Your logic is correct, but you can think of Egypt being the same latitude as like Atlanta, Dallas, Phoenix.
Oh, okay.
It's not that far. So here's our North Star. We're 43 degrees, right? North latitude, Milwaukee. The North Star would be about right here.
Okay.
So not about 10 degrees, which is about your fist held out at arm's length.
So yeah, I guess Egypt is farther north than I'm thinking. So,
yeah, it's about 30 degrees north latitude. I mean,
okay.
Of course, Egypt's a big country too, so
right.
it varies quite a bit. I mean, here in Wisconsin, if you get up to what, Superior or so up in northern Wisconsin, it's about 47 degrees. I think, no, Wausau is 45, right around there. So it's about every 70 miles you go north or south, you move 1 degree in latitude.
Right.
Approximately. So, oh, and then to finish off the Big Dipper, in some of this, we call this star hopping. We'll turn on Cassiopeia. So reach out in your sky again if you like, and follow the arc of the Dipper. And the trick they say is you arc to Arcturus, and that's how you find that bright kind of yellow-orange star. And if you do it again, arc to Arcturus and kind of keep going, then you drive a spike to Spica. So that's how you can find those two bright stars in the sky. And remember, back in the city, these two just really stand out. I mean, you don't see any of this. And one other star down here we mentioned before, Antares, that kind of red one down here. It's part of the Scorpion. We'll put the Scorpion's constellation. You can never see the tail very well. This is the stinger down here, but this is how they saw a Scorpion. And the bright star Antares represents the heart of the Scorpion. And if you translate it, it actually means a rival of Mars. And people have mistaken it for Mars many times. And we're going to we really encourage you to, as nature lovers, is to find, okay, a bunch of white lights in the sky. Well, no. You got yellow, orange Arcturus. You can definitely see Spica as blue, and you can see Antares as more of a reddish color. And that's all a sign of temperature. And anyone want to guess which color star is the hottest of the yellow, orange? It's hard to interact with these, but if anyone, Tim, you want to throw a guess out, or anyone? What's the hottest one?
Isn't the bluer the hotter?
Yep, very good, very good. And a way to think of that simply is a fire. If you look at a fire, it's the blue part next to the log or the candle wick. It's hard to see sometimes, but that's the hottest part. Now, all fires are hot, of course, and all stars are hot. And I think I have this set up. Many of you, this is seen things like this on the internet, but let's see if this works. So stars come in different colors and different sizes. So there's Proxima Centauri, which is the closest star to the sun in the galaxy, but we can't even see it, it's so small. But the sun dwarfs that, and the sun is small compared to Sirius, which is known as the dog star. We can't see that one now. It's more of a winter one. There's Pollux in Gemini, big red giant. Look how small our sun is getting back there. I mean, just crazy small. And there's Arcturus. We just were at Arcturus. We arc there. There's Rigel and Orion. Can't show you that one. But the blue stars are much hotter and put out a lot more light. And there's Deneb, another big hot blue star. There's the Pistol star. We don't see that one in the sky because there's too much dust. And that last one coming up, that last red one, was Antares. So the color, the temperature, also the red stars put out less light. And you can think of them like maybe a 100-watt bulb. And the blue stars put out much more. They're like a 1,000-watt bulb. And just to give you an idea, if we go back to the triangle here, now when you look in the sky, it never looks 3D, right? You don't see all these stars are at different distances. Now Deneb is the star that's part of the Swan, and the Swan is right in the galaxy. A lot of people call it the Northern Cross, and Deneb marks the tail right here. That's Deneb. Now Deneb is about well, let's do it this way. This is Vega, and that's about 20 light years away. Okay, that's where Jodie Foster went to. If you ever saw the movie Contact, she met her dad there. And down here is Altair. That's about the same distance, 25 light years away. Okay, but Deneb here is, get ready, 2,000 light years away. And notice they're all about the same brightness. So it's a big illusion. Deneb is just crazy hot blue star putting out lots of light, but it happens to be very far away. The other two are kind of normal stars, and they all look the same. But Deneb is just way out there. And remember, when I say 2,000 light years away, you're looking 2,000 years back in time. And that's another thing about stargazing that just kind of boggles the mind. You look into space, you look back into time. Most stars are typically 10 to 100. Like Arcturus here is 37 light years away. So if you do your math real quick, you're looking at 1984. And but then Spica is much further away. I think it's about 500 light years away. So it's kind of a strange thing when you stargaze to think of all that in the night sky. So and then remember, there's so much more than meets the eye, right? There's so much way out there. We can show you a galaxy. This is what your astronomy club there does. And right below the Big Dipper's handle, this is the Whirlpool Galaxy. Now, okay, with a backyard telescope, you're not going to see this. This is a Hubble picture, but it's still kind of cool. I mean, really cool to see it through a backyard telescope, like a 6 to 8 inch telescope. I mean, nothing like that, but it's just kind of cool. And that one is about, what is it, 35 million light years away. And you can't, even though it's a huge galaxy, billions of stars, it's so far, you can't see it with the naked eye. So that's just a strange thing about the sky. So again, if you have any questions, we're going to take a little later into the night here. Oh, before we do that, I'm looking at the time. Remember, if you go stargazing and you get away from the streetlights, you're going to see a meteor or two. Now here I can just press buttons. I don't know if you can tell, but typically you only see one every 10, 15 minutes. And then there's a bright one. And remember, it's hard to explain, or I don't know if you realized now here looking at our planetarium sky, you can see everything, right? You can see the whole sky. Well, if you lie on a blanket or a lawn chair and you look up, you see less than 25% of the sky. You don't come even close to seeing all of it. And so when you count meteors, which is great to do, the Perseids coming up in August, I imagine some of you have stayed up for that one. That is so cool, but it's fun to go with a group, friends or family, and then you all take part of the sky. Someone maybe takes the northwest, someone takes the southwest, someone takes the southeast, and you all look at different parts of the sky, and then you count together. And you count how many you can see an hour. So when you see things in the press, and I try to help the media along, when they say, well, you can see 60, 80 Perseids an hour, well, that's if you count together as a group. Individually, you're only going to see about 20 if you're out there on your own, maybe 30 if it's a good one. So that's the thing about meteors or meteor showers. And they're just real cool to look for. But it's time. I won't get into it of all the details, but it's always better to get up before sunrise, like 2-3 hours before sunrise. You'll see more meteors in the morning than you will in the evening to look for those. All right, let's keep you up a little late here and go to about midnight, 1 o'clock. And again, I'll ask you to hang on to your seats there or your chairs, because the sky's not moving. It's not moving. The reason we don't feel the earth move, of course, gravity holds us down, and we don't see it because we're all moving together, right? You, me, any house building, we're all moving together. The air moves along with us. Now we have winds, of course, but the air mass moves right with us, and we don't sense the motion of the earth. And it's a nice smooth ride, right? If the earth ever slammed on its brakes, you'd know it's moving, just like a car when it slams on its brakes. So we didn't stop the earth. The earth is still spinning. We just slowed it down to normal speed, where you just have to be outside for a while and you'll see the changes. So this is about, what time is this? Probably about 1 o'clock in the morning. And this is, of course, the darkest part of the night. We're the deepest in the Earth's shadow. There's, and we're far from streetlights. And again, I think the Milky Way is a little overexposed here. It's not quite that bright, but we have 2 planets that came up here over in the, I'm going to try to take that off. So this is Jupiter here. in the sky, and Saturn. Okay, now they're well up by 1 o'clock here, and you'll see them, and they're going to move into the evening sky by August, kind of late summer is when you'll see them right after sunset. And we hope to do maybe work with your astronomy club and do some telescope stargazing in the fall. And we're in the city here, and where you can see the rings of Jupiter, or excuse me, the bands of Jupiter and the rings of Saturn, which is kind of cool. So just like we did with Mars and Venus, which are gone now, Mars is gone. Let's have some fun with Jupiter and Saturn. Oh, Jupiter's so big, it's eclipsing Saturn there. So we have a spaceship at Jupiter right now. It's called Juno, and it just released some new pictures of one of the moons, Ganymede. That was kind of cool. And it's been there 5 years. Now, if you're someone who is more of an artistic bent, you can take images, the raw data from Juno, and you can color and crop the pictures any way you want and submit it back to NASA, and they might choose it as one of their photos for a press release. It's kind of a cool program. So there's been these kind of wild artistic type pictures, again, based on the data that are coming back from Jupiter. And your chances of winning are probably pretty small, but it's still kind of cool. And I don't have the moons, but through a small telescope, you can see the 4 big Galilean moons of Jupiter. And let's see if we can show you one. I call it the pizza moon, Io. See if Io will zoom up. There it is. So there's Io. There's
Bob,
two.
we
Go
just
ahead.
had a question in the text. Can you repeat the name of the NASA program for coloring the
Oh,
images?
I don't know. Oh, the name of the spaceship is Juno, Juno. Juno. And if you look up that and the program, you should be able to find it.
Great, thanks.
Yeah, just think of, Juno and Jupiter are husband and wife. They're like Zeus and Hera in the Greek mythology. So that was Io, and another moon, if I can bring up, here comes Europa. Europa is a moon of Jupiter. Now, again, this is not what you would see through a telescope. These are NASA pictures, and it's kind of hard to see the surface, but there's not a lot of craters. And that was a big deal because there's not a lot of craters. There's some like reworking the surface, and they have now theorized that there's water below the icy surface of Europa. And once again, where there's water, there could be life. And that, it gets scientists all excited. And why not? I mean, if we find life elsewhere beyond Earth, probably, arguably, the biggest discovery that humans could ever make. So, who knows? No one knows, but it's still fun to think about. And Saturn, and one thing that scientists like to do is make movies. So they take all the data, right, from the spaceships and the telescopes. And so Cassini was at Saturn for 12 years. Now, this is not real. This is an animation, but it's based on the data, what it would be like to fly through the rings of Saturn. So put your hard hats on here, because these rings are made up of millions of these little icy boulders. And they're not much bigger than the ice cubes in your freezer. They're about the size of your fist. Maybe, if you squeeze your head, they're about the size of your head. Some can be bigger than that, but look how many there are. And that whole ring system of Saturn is less than a half a mile thick, but it's over 100,000 miles wide, which is, just bizarre. So if you guys ever take a trip out to Saturn, that's what you'll encounter. But even if you sped down the highway 70 miles a second without stopping, it would take you 2,000 years to get to Saturn. So be a long journey. And I say that, it seems far, right? So do one thing, we talked about looking back, Saturn's light takes about an hour to get to us. Jupiter's and under at light speed, right? So 2,000 years by car, hour by light speed. Our rockets get there in about 4 years or so. So it depends how you're traveling out into space. But we have never been to another star. To get to like Altair here in the Big Triangle, Altair right here, 20 light years or so away. You know, at 10 miles a second, our top speed, it would take our best spaceship about 500,000 years to get there. So we are not going to the stars anytime soon. Who knows? Someone might invent warp drive. But it's the distance is just unbelievable. It's just crazy. All right. So, I wanted to show you the zodiac. You'll see, some things we looked at. Antares in the evening about 10 o'clock was here. Here's Antares way over here now. And Leo the Lion, if you go below the Big Dipper's over here. You can still arc to Arcturus and then speed down to Spica or Spica onto Spica. Leo's barely hanging on here. You can still head to the North Star right here. And there's Cassiopeia right in the Milky Way. So everything like the sun, right, just goes from east to west across the sky. But let's put up the zodiac constellations. We looked at a couple, Leo and Virgo, but we're going to just put them all up there so we can see Leo's back end here. So these constellations, many of you know of them. And Leo, this Virgo, that's where Spica is, Libra, the Scorpion, Sagittarius is now up, Capricornus, Aquarius, and the fish are coming up, Pisces. So these zodiac constellations are simply the path of the sun, moon, and planets. The sun, moon, and planets move in front of that because our solar system is flat. Think of a pancake or an old record album. Our solar system is flat. And so when we look along the plane of the solar system, we see the sun, moon, and planets, and these just happen to be the stars. And so these stars were revered. They were special because remember, the sun, moon, and planets a long time ago, they were gods in most cultures. They were literally gods up in the sky. So as they traveled through the zodiac, you can now sense how astrology got very powerful. And people thought, the positions of these sun, moon, and planets could predict futures and all of that. Now, from a science perspective, we of course know that does not work at all, not even close. If it did, of course, astrology would be, they'd be the richest people in the world because they could predict everything. But we know that doesn't work. So there's no scientific basis to it at all. The reason I mentioned is simply it was a very powerful connection that people had to the night sky. So it's no coincidence that Jupiter and Saturn, are along that. Mars just set here in Gemini, which has gone down. So powerful connections. Now, I like to think of the zodiac, we just pop them back. There are 12 of them. How many months do we have? We have 12. So the sun moves in front of these one per month. So if your birthday, is coming up, you never look for your sign, your constellation sign on your birthday, because it simply means that's where the sun was when you were born. And I'm not going to get into precession and the earth wobbling and all that, but feel free to contact me. So here's the path of the sun, and you can see the dates as it goes through there. And again, the moon and the planets follow pretty much that same line. And other cultures were big on this too, okay? Here's the zodiac. Oops. Oh, there they come. That was kind of strange. These are the zodiac from the Maya people in Mexico, Central America. And the Maya were very good stargazers. Their calendars were very accurate. They had 13 zodiacs. Why would you have 13 and not 12? Well, their calendar was more moon-based, and some years we have 13 full moons and some years we have 12. And so they based it on when the moon had 13 full moons. I think last year, we don't have 13 full moons. That's the blue moon. When we have two full moons in the same month, that's a blue moon. I think we had one on Halloween last year. So the Mayans had 13, and then everyone's different, right? If you go to China, they only had 4 zodiacs for the 4 seasons. So the big black tortoise here represents winter. It's kind of hard to see the face, but the blue dragon, that's a dragon, represents springtime, and the white tiger over here coming up was for autumn. but powerful connections people had to the night sky, very powerful. And it continues to this day, of course, but differently, a little bit differently. And then, oh, I was going to see if we have this. I want to invite you back. I'm sorry, I got to do some advertising. I want to invite you back to the planetarium here and see if this is coming up. No, it's not. I was going to show you. It's not hooked up. I wanted to show you a preview of our Constellation Show, which is going to premiere when we open next month. The planetarium, the museum is open. The planetarium in the Dome Theater, we hope to open July 22nd. July 22nd, that's our goal anyway. All right, before we take a look at the morning sky, let's do something kind of beautiful. I don't know how many have seen it. Maybe you can send it on the chat function, but we'll show you our rendition of the Aurora Borealis. And this is very, very rare. And it's just gorgeous. Mostly green. It's kind of a soft glow usually in the northern sky, and it sort of dances, but it's our atmosphere glowing. It's being electrified. A one-word answer for the aurora is electricity. You heat up a gas and the gas will glow. And we mostly, due to the chemical of molecule of oxygen, we mostly see the oxygen glow, which usually glows green, but sometimes it can glow red. And so usually aurora will be green and sometimes a little red. We rarely see the nitrogen in our atmosphere that will glow a kind of a purple, bluish color, but that's much more rare. So it depends on where these particles are hitting our atmosphere. So who's heating up the air or making it glow like that? Who's electrifying our atmosphere? It sounds kind of scary if you think about it. Well, it's the sun. And so we're going to show you a cool time lapse. This is real, actually, from NASA's telescope up in space. And this is real imagery of the sun. I want you to look right in here, right where the mouse is, right there. You're going to see a big explosion. Boom. That's a solar flare or a coronal mass ejection. These are magnetic, you can see the loops there. These are magnetic field lines. When they snap, they release charged particles, mostly protons and electrons. And if it's strong enough and it's aimed at the Earth, it's gonna slam into the Earth, but most of it's gonna get deflected because we live on a magnet, right? We have a magnetic field. So all this stuff usually goes around it. But some of it gets trapped in the magnetic field lines and then it comes spiraling in toward the magnetic poles, which are near the geographic poles, and it starts lighting up the night as these particles slam into our atmosphere. So that's why the further north you live. And if you guys want to take a quick trip to Alaska, let's hop on board. We're going to take a very quick plane ride to Alaska, and they see the Aurora Borealis all the time. I mean, not every clear night, but like every third clear night I mean, you talk to an Alaskan, they'll just shrug their shoulders. Oh, the Aurora. Okay, yeah. Oh, you must be from the 48. Because this is just beautiful time lapse stuff of the Aurora. Now the museum, we hope to plan a trip to either Alaska or Iceland, or the Scandinavian countries are also real good. But they see it all the time, and it's just a lovely sight. And I'm sure many of you know, the further north you go, in Wisconsin, you'll have a better chance of seeing it. The UP, Minnesota, any place up there, you see it much more. You know, we're talking about latitude. You know, our latitude is 43 degrees. We're closer to the equator than the North Pole at 43. So we don't see it much here in southern Wisconsin. It's kind of rare, but you need that big storm in the sun. And there's a website called spaceweather.com. If you go there, spaceweather.com, you can get alerts, aurora alerts, when there's a good possibility, because these particles from the sun, they take about a day or two to reach the Earth, so they can predict when there's a good chance. They can't predict that you're going to see it, but a good chance. And a great Facebook group is the Great Lakes Aurora Hunters. I think that's the name of it. And it's great because they get online and they tell you, I'm seeing it here, I'm seeing it here. And it's really cool. You can get it directly from people who are witnessing it. But the aurora is another thing that you need to get away from the streetlights generally. It's even more rare that you would ever see it in the city. Though I have a few times, but it's pretty rare to see that. So again, that's the aurora borealis. All right, if anyone has any other questions, we'll finish up on the morning sky here and take you to just before sunrise, which is not far from now, right? It's, boy, I hear the birds chirping at 3:30 and it's just crazy. So let's spin our Earth here. I hope I don't have it too far. Here we go. So Jupiter and Saturn get higher in the sky. Yeah, might slow it down here a little bit. Hang on. I'm gonna go into about, back up a little bit. Yeah, I think I had it set. So where are we in the sky here? Yeah, so the sun's come up. So here's our morning sky. You can see the glow with the sun about to come up here. So here is, if you look south, you'll see Jupiter and Saturn, no problem. And again, we're still in the country, we're still in the woods, but with the sun coming up, it looks like we're back in the city. And you'll notice our urban summer triangle here, just really standing out in the sky here. So the bright star Capella. So there's not too much else to see in the sky as the sun's about to come up. Those are some of the things you can see on any clear night. On these short nights, what is it? We have 15 on the solstice coming up. God, what's the day? Already 10 days of the solstice. The total amount of daylight for the Milwaukee area is about 15 hours and 20 minutes. Okay, 15 hours and 20 minutes. And it's just the opposite in winter. On the winter solstice, we have about 9 hours of daylight. And of course, it gets more extreme the further north you go. If you went to Alaska, it would be the midnight sun. And I'm sure many of you heard of that. Some of you may have even experienced the midnight sun, where the sun doesn't even go down below the horizon, which is kind of a strange thing. The tough thing about that, though, is we did it in Iceland a long time ago, is just staying up all night. That's the hardest thing, but it's kind of cool when the sun doesn't go down. All right. I can show you before I kind of wrap up here, and I got all the sky up. Does anyone want to see anything before we go? I don't know if you can read my kind of cheat sheet here. There's lots of cool things I could show you. The one thing I'm going to show you as you think about it, I'm going to show you more about the solar eclipse. I'm not sure how updated this is, but so this is, remember, April 8th, 2024. This is going to happen, not in Milwaukee. Close, 90% though, but you want to get into totality. And if you've never seen totality, this is when, there it is, the moon blocks the sun. You get a handful of stars, not a lot, and it only lasts a handful of minutes, 2, 3, 4 minutes, and then the moon keeps moving. So yeah, I didn't update the times. We were down in Chile for that one, but here's the date you want to go. April 8th, 2024. And try to get there. That's the Chile one. I'm going to show you the path here in just a moment. There it is. This is the path you want to go to. We're going to be in Texas near Austin, but here are the cities. And of course, you can just Google that too if you want to. If you don't travel, the next total solar eclipse in Milwaukee is 2099. And the last one in Milwaukee was 1379. So total solar eclipses happen on average about once every 18 months. But if you don't travel, the chances of you seeing one are pretty small, but it's kind of cool. So we'll wrap up here with the sunrise. And if anyone has anything else, just let me know. There's our sun. Hey, sun. So it was pretty cool to see it rise eclipse yesterday. That was kind of neat. That was kind of cool. And we're back. I don't know if you can hear my audio here. We can even have the Beatles singing here. So congratulations, everyone. You stayed up all night. We can do our big thank you too. So that's what I got. Come visit us at the planetarium when we open in July. I mentioned the Constellation Show. We're going to also have if you can, boy, I know that got bright. A to Z Astronomy Show coming up in the fall. Just a fun romp through the universe, taking on through the alphabet. And here's our Stargazers of Africa. We're going to be playing that right when we open at the end of July. So that's it.